All right, we are going to look at a second example, which involves Venn diagrams. All right, on this example, I'm just going to write down the question. During registration at a certain school, all students had to indicate which mode of transport they use to come to school. Below is the data captured. All right. 434 students on foot. 288 students on foot only. 299 by private transport only. 571 by public transport only. 29 both on foot. 29 both on foot and private transport only. Maybe it's only. 56 both on foot and public. Transport only. Then 210 both by private and public. Both by private and by public transport. Then 42 students used others. 42 students used others. Okay, this is the, let me just cross check quickly. 434 students on foot, 288 students on foot only, 299, then 571 public transport on, 29, and 56, and then 210, then 42 used others. Okay, then the first question is that draw the Venn diagram. This is the first question. Draw the Venn diagram for the data above. Okay, we are going to draw the Venn diagram. We can see that we've got foot, and then we've got private, and then we've got public, then we've got others. This represents others. So this is the Venn diagram, which is like this. Then others, we can see that 42 used others. So this is 42, this is 42, and then this is foot, and then this is public, private, and then this is public. Okay, this is like this. And then let's go back. 434 students on foot. So on foot, we are not told only, it's only on foot. So on foot, we know that it's 434. All right, it is 434. I'm going to erase this 434 after drawing everything. And then 288 students on foot only. So this is 288. And then 299 on private. 299. And then 571. Okay, we have used this and this and this. 29 on both foot and private only. So this is 29. And then 56 on both public, 56 on both on foot and public transport. Foot and public. How many are there? There are 56. Okay. And then 210 both by private and both by private. Let me just check if it's only or it's not only. So it's 210. So 210 covers this. It's not only. So let us call this X. X, let X be for all the three only. So it's X there. But we are told that it's 210 for both private and public. So it's 210 minus X. Because we don't have only here. So it's for this part. If it is got only, it was going to be for this part. But now there is no only. It's only 210 for private and public transport. There is no only. So if it is only, we're supposed to write 210 here. But now it's not only, it's for everything here. So it's 210 minus X. Okay. Then the next question they say, draw a Venn diagram to depict. Okay, I've done that. Determine the number of students who use private and public transport only. The question is, determine the number of students. Determine the number of students who use private and public transport only, and public transport only. All right. Private and public transport only. So in other words, we need to add this and that and this and this and this. Private and public transport only. So we need to add this and this and this. Because this one is it's on foot, so we don't include this. We want those ones who travel by private transport or public transport only. We mustn't, in those people that we are looking at, we are not supposed to find people who use foot. So only it includes this one and that one and that one. That's private and public only. So in other words, we must have the value of X. So how do you get the value of X? We are told that it is 434. Can you see this 434? We know that it's 434 for people who use foot, which gives us 288 plus 29 plus X plus 56. So therefore, we're just going to say 434 minus 288 minus 29 minus 56. So therefore, X, it is equal to 61. That's our X. So for private, number of students using private and public only is equal to 299 plus 210 minus X. Our X is 61 plus 571, which is going to give us 299 plus 210 minus 61 plus 571, which gives us 1019. So that's the number of students who used private and public transport only. All right, we'll move on to what is the probability that a student chosen at random come to school by private transport only? Okay, let me just erase this information, because now we know that x is equal to 61. We know that x is equal to 61. They say that determine what is the probability that a student chosen at what is the probability that a student chosen at random, what is the probability that a student chosen at random came to school by private transport only. Private transport only. I'm talking about only. Private transport only. You go on to private transport. There is the private transport, and we want private transport only. We can see that it is 299. So in other words, it is private probability of, first of all, you must get the number of all students. So number of all students is equal to, you add 288 plus 29 plus 61, because x is 61, plus 56 plus 299 plus 210 minus 61 plus 571. Why did I say that? Number of all students, then plus 42. Okay. Why did I say that? Then all the number of students, you're supposed to say this plus this plus this plus this plus this plus this plus that plus that. So it's 288 plus 29 plus 61. X is 61. We find out that x is 61 plus 56 plus 299 plus 210 minus 61, because x is 61, plus 571 plus 42. So I'm going to use a calculator quickly. So it's going to be 288 plus 29 plus 61 plus 56 plus 299 plus 210 minus 61 plus 571 plus, so it's 4095, which is equal to 4095. So probability of using, what is the probability that a student chosen at random came to school by private transport only? So you go into private transport only, which is 299. So by private only, whatever you're gonna say, it is 299 over 4095. That will be the this is 299 divided by 1495, which is 1 over 5, which gives us 1 over 5. Then the last one, what is the probability that a student chosen at random came to school neither on foot? Okay, let me just erase this part. So that we do this question. What is the probability that a student chosen at random came to school neither foot? No. By private, or by public, sorry, public transport. Okay. All right. So in other words, we are looking at a student who did not come on foot, or what did they say? No. So we are looking at a student who did not come on foot or by public transport. So let us go on to foot. So we don't like this. We don't like this part. And we don't like, they say on foot and on and by public. So we don't like this part. We don't like this part as well. So the only part that we need this one and this one. So in other words, we are going to say probability students on foot, no, by public transport is equal to 299 plus 42 over the total. We find out the total is 1495, which gives us 299 plus 42, which gives us 1495, which is 341 over 1495. Okay, that will be the answer. So that's how you approach these Venn diagrams. On Venn diagrams, you're supposed to recall only, and when they say A, and then A only, or when they say neither A nor B, those are the things that you must take note of. All right, we are going to look at an example which involves a tree diagram. Probability which involves tree diagrams. For example, you'll be given a question like this. They say bag A. Bag A contains 9 marbles. Five are red, 5 are white, and 4 are red. Okay, and then bag B contains 8 marbles. 3 are white and 5 are red. 3 are white and 5 are red. A bag is picked at random. A bag is picked at random. And a marble is picked from the bag. And a marble is also randomly picked from that bag. All bags have equal chances. All bags have equal chances of being picked. And same applies to marbles. And the same applies to the marbles. All right. The first question, A, draw a tree diagram for the above information. Okay, we want to draw the tree diagram for the above info. All right, first of all, there is bag A. So the tree diagram, you're supposed to draw it like this. There is bag A. Okay, this is bag A, and then this is bag B. And we are told bag A contains 9 marbles. All right, so what is the chance of picking bag A? It is half, because there are 2 of them, they're equal bags. So it's a half. They've got the same chances of being picked. So the chances of picking bag A is half, the chances of picking bag B is half. Then 5 are white and 4 are red. So if you choose A, let's say it's bag A which is picked, and then we are supposed to pick a marble there. So what is the probability of picking 5 ones? So it's 5 over 9. So here it's 5 over 9. So this 5 over 9, which is white, and then this is red, which is 4 over 9. All right. Maybe sometimes you do not pick bag A, you pick bag B. What is the probability of picking a white marble from bag B? So this is white. 3 are white, so it's 3 over 8, because there are 8 of them. And then, so it's 5 over 8. This is white, this is red. A bag is picked at random, and a marble is also randomly picked from that bag. All bags have equal chances of being picked, and the same applies. And the same applies to the marbles. Okay, so this is your tree diagram, and you are supposed to write the outcomes. So this is bag A and white marble. This is bag A and red marble. These are the outcomes. So the outcomes. So this is bag B and white marble. This is bag B and red marble. Then the probability for picking bag A and white marble, you see now end. So you're supposed to say half multiplied by 5 over 9. So this is half. So this is the half and the 5 over 9. That's why you get half times 5 over 9. So this is half and 4 over 9. So it's a half multiplied by 4 over 9. Okay, then the same applies here. It's half multiplied by 3 over 8. It's half multiplied by 5 over 8. So this is the outcome. That's the tree diagram. These are the outcomes. Then the next question is that determine the probability of picking a red marble. Determine the probability of picking a red marble. From bag B. From bag B. Okay. We want a red marble from bag B. So in other words, we want BR only. So this is bag B, a red marble. So we take this. This is the one that we need. So in other words, we're going to say probability red marble from bag B. I'm just going to say half multiplied by 5 over 8, which gives us 5 over 16. Okay. Then let's go on to the next question. Determine the probability of picking a white marble. Determine the probability of picking a white marble. Okay, where do you get my white marble from this tree diagram? You look where there's white marble, which means you're looking for there and there. So in other words, you're going to say probability of picking a white marble is equal to half multiplied by 5/9, which is this one, plus half multiplied by 3/8, which gives us, I'm going to use the calculator quickly. Which gives us 67/144. That's the probability for picking a white marble. So white marble, it's irregardless where the marble is coming from, whether it's coming from bag A or from bag B. It must be a white marble. So we only get this and then, which is this one plus that one. That's how we do it.